let's still try to see if we can fit this geometric operations part into this lecture. There shouldn't be too much stuff, so I think we might manage. So the idea is that we go and have some sparkling wine at 2, so we should leave at, well, 5 to 2 to the geology. So we want to be on time on that. So let's just continue some 20 minutes more with the geometric operations part, and then we can have a break and, well, we finish then, and then we can enjoy the sparkling in peace. So the next topic are the geometric operations. So I just quickly want to demonstrate how you can do these simple overlay analysis, where you can clip data from a layer using another layer as the kind of clipping feature. So for this purpose, we will use the Helsinki borders data and the travel times, so that the same travel times data set that we just used. Again, I will create a new file. So let's call it overlay analysis. And so what we want to do now, we want to read some more data. So here we already have these travel times in our IPython console, but we want to read these Helsinki borders inside as well. So let's say HKI, so Helsinki file path equals to this one, and now we have that inside, and I just border, well, yeah, I call it hell. So hell gpd.read file, and what I want to read is this Helsinki FP. And what we have here is, it seems that we only have one polygon inside. Let's take a look what it looks like. Okay, we have this kind of layer with only the boundaries of Helsinki region, and then we have the grid. Maybe I still take this as well so that it stays intuitive. So grid FP equals to, so we have this travel time grid to railway station, and I call it grid gpd read file and grid FP, not that one. And then with F9 I execute it. To define the variable first, and now I also have this grid. So this is the same accessibility layer that we just used, like this, but now without the classifications or anything like that. So always now, as we are doing the kind of want to do overlay analysis, so clip features from one grid and to select those things, so we want to check that the coordinate reference systems are the same. So that's of course really important, because the coordinates of our data has to be exact, using the same projections, so that we can actually do some overlay processing on them. So check coordinates ref systems. So hel.crs and grid.crs, and what we want to have is that they should be the same, and indeed they are. So this is always an important step if you're working between the two different layers, to check that they are the same. And then what I would of course next do is that I want to plot them, but yeah, okay, well, I don't seem to have that plot in here, but well, what you would see is that the Helsinki borders basically go on top of the accessibility layer, the grid that we had, and that's it. So what we want to do is that we want to produce this kind of output. So we want to use the Helsinki polygon, so the boundaries of Helsinki, to actually clip this polygon grid that we have. So we can see that the boundaries here, they actually kind of clip those features from this other one. So let's take a look how we can do that. So there is a really handy function in GeoPandas called overlay that we can use. So let's take the intersection between the layers. So let's say that the result equals to, can you see it? So gbd dot overlay. So here we have this function that takes two different data frames, so data frame 1, data frame 2, and then we have this parameter how. So this is basically how we define what kind of operation do we want to do. So do we want to intersect, do we want to take union, or what kind of process we want to do. Again, it's good to go and check the GeoPandas documentation to actually see what we can do. So there's plenty of information available at the documentation of GeoPandas, how these actually work. So this is a good place to go and check out and check for understanding what we can do. So we can, as said, we can do intersection, we can do union, where we actually combine these two features together, and then we can make a difference, and a symmetrical difference, or then the difference. So we will actually erase something from this data frame 1. So let's see, and what we want to do here is that we want to take and cut, we want to cut these, or take the intersection between this grid and then the polygon, the Helsinki borders, so with this layer. So as the data frame 1, we specify, so from which should we do something or take something, it's that grid layer, and the data frame 2, so which layer should we use to take the intersection is the Helsinki borders, and how. So with this how parameter we specify that we want to take intersection, and this is basically how we can do it. This might be a rather time-consuming operation, but let's see how long it takes. It might take a while. In the website, so what we will basically have indeed is that we will have this kind of layer where we have taken the intersection between these two data frames. And we will also have only those rows available that are inside that polygon layer here. And that's basically what it will do. There is a hint, so in the Helsinki region we have 13,000 polygons, and intersecting and doing some kind of geometric operations with such many polygons is quite CPU intensive task. So it might be useful to actually kind of batch process it, which makes it much faster to run. And there is an example how you can basically do that. So this is actually doing just the same thing, but we basically define that, create it and run the process in 10 different patches, and then we basically do the same overlay using or doing it like part at a time, and it runs much faster than this process that we had here, although we had it now already. So as a result, we have these polygons. Let's see if we plot it. Result plot, color is blue. So let's check that we should have this similar output that we had here as a result. The next topic is basically how we can aggregate data. Basically, this is a similar process that what we would do with pandas aggregation that we have done already. So we use if you have combine all the travel times that are like 5 minutes and put them in as one feature, and all those that which are 6 minutes and so on. So it's the idea is really similar to what we have seen already when using this group by function, for example. But in GeoPandas there is this nice function called dissolve that can be used to indeed dissolve these different features based on some common values in some of the columns of your data frame. So there is an example in the materials how to do that, and you can check it out. It's fairly easy to do and can be handy in some cases. As a result, so now we really saw that okay, we indeed had this kind of intersected output as from our intersection between those two layers and the overlay function, and it seemed to work all right. There is also some maybe not that important, well, it might be important, but you don't need to do it in the exercise, but there is some materials about simplifying geometries, which might be useful in some cases. So if you are, for example, making global maps and you have really detailed information about the shorelines, for example, so it might take forever to actually produce the map, and you don't really need that information because you don't have you are not able to see those little details. So it might be useful for sometimes to simplify those geometries. And there is an example where we'll basically I show you how you can use this this simplify function, which is again integrated into GeoPandas. And basically what it does is that basically uses some kind of tolerance to reduce the nodes in the geometry. So in here we basically specify that use 300 meters, and the inputs are again, they are the kind of such units that are specified the projections of your data frame. So, but in this case, use 300 meters as kind of tolerance to simplify your geometries. And it's really easy to use. And as an output, the example here is not really good, but basically there is some difference between these two maps, even though it's quite hard to see from the example. But if you look closely, the geometries are here more smooth than in this one. So that's kind of maybe something good to know, but it's not needed in the exercise. But yeah, let's go to the exercise 4. I know this has been now quite fast lecture, but hopefully you have kind of understood at least most of it. In the exercise 4, what you need to do, this might be a bit challenging. How was the exercise 3? It was okay. Good. Exercise 4 is kind of a continuation of that exercise 3. So again, we go with really practical example, and what we want to do here is that we want to find and define dominance areas for different shopping centers. Is dominance areas familiar term for you? So what we mean by dominance area is that you want to find such areas, service areas are kind of similar word for them. But if you have 7 shopping centers in Helsinki region, so you want to find and define those areas where it is fastest to go to certain shopping center. So, for example, around Jumbo, you might have certain area from which it is always fastest to go Jumbo, and other place in some other shopping center. Yeah. The idea is a bit similar, but Voronoi polygons are basically just based on the locations of the geometries. But the idea is somehow similar, but what we are doing here is that we actually have the travel time information from the grid, and we basically try to find the minimum values for each shopping center, and then we plot it. The exercise might be a bit challenging. There is quite plenty of hints this week in here. Hopefully they will help you. I will actually, now there is not an example what we are actually looking after, but I will add an image so that you can see that what kind of map you should have as an output. But basically there are 3 problems, and you should basically answer to each one of these. The first one, basically, there you just you want to practice, or you need to practice to use these classifiers of spatial, or use your own classifier. But it's just to get practice of those a little bit. And then the problem 2 is really to calculate and visualize the dominance areas of shopping centers. And there are quite a lot of different hints and kind of steps that you need to do it. Hopefully they are clear enough. Again, Slack is available for you, and now I have more time to also answer to you, and also the assistant, so hopefully you will get it through. And the problem 3 is again similar, so we want to know how many people live under those dominance areas of those shopping centers. So that's the exercise for this week, and yeah, I hope it will be a good one. So if do you have any questions about anything? Yes? Yeah, it's required if you want to use those ready-made classifiers. Let's check the installations maybe after the sparkling, because it's really useful package in general to have. So it's nice that you can have it available. Any other ones? Okay. If not, so let's continue. So on Thursdays there will be the practical session, and then next week we will do the fun stuff and start visualizing stuff and do interactive maps and so on. So it should be fun. So enjoy.